This is the first installment of Audacious Little Things. Meet an anthropologist who explains why she thinks the human animal delights in making miniatures of things.
My preference is for the wonder of very small things, which help us to reduce our own importance sometimes.
Then meet a sculpturist dubbed the eighth wonder of the world, whose art requires a microscope to see.
My mum would tell me to show the world how big nothing is. Show them that how big small things really are.
Find out how one type of hydrozoan earned itself the title of the Immortal Jellyfish. Plus what researchers think is going on when starlings fly together in those mesmerizing clouds, and what that has to do with creating underwater robots. Finally, former U.S. and New York State Poet Laureate Billy Collins reads his piece The Butterfly Effect and ponders the reason why we are so compelled by the concept. I'm Kyone Wolfe. That's coming up next on Audacious, after the news. From Connecticut Public Radio in Hartford, I'm Kyone Wolfe, and this is the first installment of Audacious Little Things. You're going to hear about tiny animals in the sea and sky who make a habit of totally blowing our minds and influencing our technology, and we'll wax poetic about the butterfly effect with poet Billy Collins. But first, tiny, so small art. In a zeptosecond, more or less, you're going to meet an artist referred to as the eighth wonder of the world for his sculptures that require a microscope to make. But before we meet him, it's important that we contemplate why, in the world, the human animal so often feels compelled to make big things small. Mary White is a professor of anthropology at the College of Arts and Sciences at Boston University, and she studied this phenomenon. We connected recently to talk about it.
I love this topic, by the way. We've been, in the last year and some months, living in much smaller worlds than we usually do. So there's something about glorifying the miniature or bringing it out that kind of justifies or makes it feel better that we've been living constrained lives. To think about the small on purpose is great. So I'm glad you are doing this.
Well, if it's possible, we could just jump right in. I'd found you after reading this beautiful pondering of yours about why we're attracted to miniature things. And I'd like to start at the beginning of your statement when you said, people often say our love of miniatures is about control. So tell me more about what you think control has to do with it.
People do think that our admiration or kind of fixation on small things is because we can control small things and we're bigger than they are and we're glad to be large in some context. And we manipulate small things. We can do stuff with them. So thinking about very small things is kind of like, but the flip side of thinking of very big things. Walking into a European cathedral, the enormity of it, the tininess you are, you're like an insect in this enormous space. And you see beams of light coming through stained glass windows. God is there, this enormity of it. But if you flip that around, small things are equally awesome. They're wondrous. And meticulously reproduced small things give you the same sense of deep breath. Oh my goodness, this is amazing. But I think my preference is for the wonder of very small things, which also help us to reduce our own importance sometimes. You can both have the control over the small thing, but you can also feel less responsible, less adult. You can feel like a child yourself again. But miniaturization allows you to imagine things like there's a whole universe in this pore of my arm, and that doesn't make you powerful. That's the opposite. It makes you feel, wow, the galaxy is here, So, you use binoculars and telescopes to see big, far away things and make them bigger for you so that you can own them in your mind, right? But I like to reverse the binoculars or the telescope and make the big things smaller, so that can make it more comprehensible, not just about control, but comprehension, or even less scary if it's something truly scary.
And when it comes to miniatures, there's also like a playfulness to it too. You've brought that up
Yeah.
as well. It touches on a playfulness that, you have this unspoken permission to embody as a child, but when you get into adulthood, it's not accessible in the way it once was. And so you think this is a connection with that playfulness.
I think the word permission has a lot to do with it. I'm glad you used that word because you're given permission to play and to control. It's also a kind of playing God as well, a kind of saying, I have ordered this universe.
Now, you've studied a lot of material and popular culture in Japan, as well as how Europeans and we Americans are so interested in tiny things. Are there any patterns that you see when it comes to the psychology of miniaturization that we all share?
The illusion of comprehension that we gain from making something or appreciating something smaller than ourselves, but actually larger. That is, something larger than ourselves. Train sets, though, are a good example of, the power over, when they were first created, is the power over these enormous things that were tying the nation together. The train was one of the most powerful symbols of nationhood and connectivity in power, economic power. But you had a train set in your basement, and you could make these adorable little trees out of, moss or something, and you could make the whole of the country yours. That to me is kind of the ultimate American joyful miniaturization, at least of my era.
It's so funny because you mentioned model trains, and I think, of course. They're so ubiquitous, especially in the United States. And you've been to Japan, spent a lot of time there, and there must be many things there that are as ubiquitous as a model train set in the United States.
In Japan, you get these little gates, they're called tori, that you can take home and make your own shrine. Or if you're going to a Buddhist temple, you can get figures that you then put in your home. I love these. They're like dollhouses. They're called butsudan, or Buddhist shrines in your home, where you pay respect to those who've gone before you, your great grandparents or somebody. You put these small versions of things that are in the big temple, and little kids, love to play with their Buddhist altars because they have tiny things in them. Even the gods can be miniaturized and brought home.
It reminds me of when it's Christmas time and you have like a nativity scene.
Yes.
And you've got the little baby and the three wise people and the horse and the goats. And it's always so much fun to set the scene, and one of us kids would inevitably steal baby Jesus and hide it somewhere and mess with it. But yeah, it makes me think of that too.
Absolutely. You have permission to play. All of these things are kind of elevation by reduction.
Elevation by reduction. I think we just came up with the name of this show.
Yeah. What about the diminutive does not diminish? You increase the imaginative power of something by reducing its actual size.
That's the subtitle.
Yeah, but I do think it really is the flipped version of that cathedral experience. Being in the presence of God can be overwhelming.
You can't touch it. You can't feel. I mean, you just stand there and you absorb the space, but that stained glass, you can't touch it. That light, you can't mess with it. That sound, it controls you. It goes through you. Everything of that environment, you are in awe, and also it's impossible to control anything. And so invert it.
Yeah. The other thing about smallness is that it's hard to achieve the intricate detail of the original, but doing that becomes an important part of the craft of smallness. People used to give me in China when I was there, tiny sculptures on a rice grain, a grain of rice, a little Buddha carved in a grain of rice. You'd have to look at it through an enlarging
magnifying glass.
Yeah. That art of reduction also makes it a wonder, that you can get all that detail. You can't just have some kind of generalized version. It has to be very specific and tiny in manipulated detail.
And it's a tribute to the thing. To bring it down onto a smaller level and retain those details is a tribute.
Yeah, I think we have the capacity still to have that wonder, that awe, without actually climbing Everest and going to the temple on the hill.
Well, Mary White, professor of anthropology at the College of Arts and Sciences at Boston University, thanks for talking with me.
Thank you. It's been a great pleasure. This has been so much better than grading papers, I can't tell you. But I got to go back to that.
Well, thanks for all you do. Well done. I'm glad you took the time.
All right. Thank you. It was really fun.
Okay, now imagine you're looking through a microscope. You see at first the eye of a needle, and then you see inside the eye of that needle is a sculpture. No, sculptures of 14 camels in the eye of a needle. And just one of those camels isn't even the smallest thing Dr. Willard Wigan has sculpted. He set a Guinness World Record in 2013 by taking one of his beard hairs, drilling a hole into it, and embedding inside it a sculpture of a 3-micron long golden motorcycle. But that wasn't small enough for Willard. Oh no. In 2017, he broke his own record by taking an even thinner bit of hair and implanting in it a sculpture of a fetus. It's 0.078 millimeters in length and 0.53 millimeters wide. In other words, you're going to need that microscope. Willard started developing this skill when he was 5 years old. He didn't know it yet, but he had dyslexia and autism. And when he did poorly in school, his teachers humiliated him in front of his classmates. They warned them that if they didn't do their work, they'd end up like Willard. He ran away from school one day and blew off some understandably pressurized steam by tossing a ball around with his dog. But when the dog stomped all over an anthill, sending hundreds of little ants scurrying, Willard felt horrible. It was because of him, he felt, that these ants were now homeless. So using tiny splinters of wood, he began to construct new homes for them, the newest, tiniest apartment complex in town. And then he made them shoes, and then hats for the ants, ant-sized hats and shoes. Now in his early 60s, Willard told me that when his mother saw what he'd done all those years ago with the ants, she told him,
if you make things smaller, your name will get bigger. So you know what I did? I got a toothpick and I carved all the Beatrix Potter characters on a toothpick. You've heard of Beatrix Potter?
Yes, sir.
And my mom said, too big, not small enough. So I got the point of a toothpick and I carved a little bird on the point of the toothpick.
And you don't have a microscope at this point?
No, I was doing it by eye. I was only a young kid by eye. And then when she's seen it, she said, it's still too big. So now, if you tell a kid who's autistic that it's the best, but it ain't small enough, then the possession kicks in. So now I am now possessed to become the greatest micro artist in the whole world of all time. Because now I'm now driven. Every day of my life was to create things that couldn't be seen. My mum would always say to me that you can say lots of words and mean nothing, and say a few words and mean everything. So my mum would tell me to show the world how big nothing is, because nothing doesn't exist. So show them that how big small things really are. So from the age of 5, I never stopped making small sculptures, never, ever stopped. And I was never satisfied. What I did, I was never satisfied with, because I kept thinking it's not small enough.
So I want to give my listeners an historical sense of what you've used for tools in your sculptures. For example, you've made a paintbrush out of a single hair from the head of a dead fly. And this blows my mind. As a tribute to Buzz Aldrin on the moon with the American flag, you recreated that in the eye of a needle. And in order to get the flagpole, you snatched a piece of dust from the air. Like when you walk into a sunny room and there was dust in the air, you pulled dust from the air to make the flagpole. What?
Well, I could see some of them had shapes like look like angels flying around. So I used to take them out the air, and I wanted to find things that were so tiny that you just couldn't see them. I wanted to make them become a part of me. It depicts me for who I am. I wanted to show the world, how big small things really are.
Will you talk too about how you've used your body? I mean, when you're working on such a small level, your pulse, your respiratory system, you have to work within the most subtle movements of your body. And I've even heard you refer to your pulse as a jackhammer.
That's right. That's when I'm carving a grain of sand, I use a tiny little broken piece of diamond and put it inside an hypodermic. When that's inside the hypodermic, I would use my pulse as a little jackhammer to chip away. There's no way I could just use my physical force. I'd have to use my pulse. You see, you get these external forces that interfere with you on a microscopic level. You get static electricity, there's surface tension, there's all types of stuff that interferes with you when you're working on this molecular level. And what it does, it can actually destroy the work. So the only way to do it is by working between your heartbeats.
And you've inhaled your work before, too, accidentally, of course.
Yes, I have. I did one of Alice in Wonderland. I inhaled Alice.
Somehow appropriate. I don't know why.
Well, my girlfriend at the time burnt my apple pie, and I was a little bit upset. And I went, "Oh no!" And I inhaled Alice.
When I see your work, I smile. I hold my breath, apparently sympathetically. What other kind of reactions do you get to your work?
They've all said, this is the most amazing thing we've ever seen. The Queen of England was so overwhelmed when I made a small crown for her on the head of the pin in 22 karat gold with all the little gems inside the crown. The Queen wanted me to deliver this tiny crown to her at the palace, which I did. And it was, I would say, the biggest moment of my microscopic career. The Queen of England wanting one of my sculptures. How big is that?
Yeah, how big is that for something so small?
She said it's the biggest, smallest gift she's ever had. There's a saying, little becomes much in the master's hands. So I wanted to make little become so much more. So it speaks for me. So my work would speak for me. I wouldn't have to, it's like a defense system, because I can't read, I can't write very well. So my work is going to articulate for me. It's going to talk for me. And it does. Because when children come to my exhibition, they go, oh, wow. I've had people cry, I've had emotional things, all types of stuff.
Yeah, children, adults, queens.
Yeah. When you hear people saying, oh, I can't believe this is amazing. Then people call you the eighth wonder of the world. And people in the nanotechnology department can't believe what you've done. And it's amazing to know that something so small can have such a big message in the world and say so much.
Your story it's like made for a movie. And so who would play you in the movie of your life?
I don't know. Idris Elba, probably.
I can see that.
They are talking about doing a movie about, you know that already. Do you know that?
No, I didn't know that.
Yeah, they're talking about it.
Clearly, I didn't even know that, and I suggested it. Is how great an idea that is.
I would like a movie about it. I suppose it'd be a very inspirational one.
Well, Willard Wigan, thank you so much for your time and your brilliance, and thank you so much for talking with me.
Thank you very much. One day I may make a little one of you.
Don't get my hopes up, Willard.
Well, we'll work something out. We'll work something.
All right, we'll talk. Yeah, well, my public radio career is going to get huge, so I'll be able to afford a commission instead of waiting for you to surprise me.
Yeah, but I'll look after you. I won't. I'll look after you. We'll work something.
I look forward to it. Thank you, my friend.
Thank you.
You can see a few photos of Willard's work at ctpublic.org/audacious. When we get back.
It looks magical, and it does look choreographed. It looks like maybe there's a leader, but there isn't.
Audacious little animals. One immortal, the other with the ability to both hypnotize humans and inspire a powerful technological feat. Plus poet Billy Collins on the butterfly effect. I'm Kyone Wolfe. This is Audacious Little Things. Stay with me. This is Audacious. I'm Kyone Wolfe. Today, Audacious Little Things. Later, you'll hear poet Billy Collins pondering the butterfly effect, but for now, let's consider some audacious little animals, starting with starlings. If you've ever seen a murmuration of these little birds, you know exactly what it looks like. I like the way senior scientist for the Peregrine Fund, Granger Hunt, describes it. They are a cloud of quick gray motion, a presence in the forefront, then rapid withdrawal. A dazzling cloud, swirling, pulsating, drawing together to the thinnest of wastes. A fluid choreography of funnels, ribbons, and hourglasses, spills and mixing, ever in motion, dense in one moment, diffuse in the next. We'll have a video of this hypnotic sight on our webpage so you can wonder along with me, how do they do that? Naturally, then, in classic human being tradition, we must next contemplate the ways in which we can use these birds' ethereal abilities to create an army of underwater robots, which will do our bidding. Naomi Leonard is a professor of mechanical and aerospace engineering at Princeton University, who's developing said underwater robots in just this way, inspired by the flight of starlings. But first, I wanted to hear what she thinks when she sees these hundreds or thousands of starlings doing their magical sky dance.
I would say it truly is audacious. I mean, they are, this is a group of individuals. So individuals are somehow responding to their neighbors, to their local environment, staying together in this cohesive group. It looks magical, and it does look choreographed. It looks like somebody is orchestrating, somebody is telling everybody where to go. It looks like maybe there's a leader, but there isn't. There can't be, because it could be at any particular moment that, one or, a small little subgroup would sense the predator or would feel the gust of wind. And somehow this just spreads, and so quickly through the whole group that they don't splinter into, run all different ways. They stick together. And it's incredibly inspiring, not just because, we're fascinated to understand how it works, because it's so beautiful, but also because, as an engineer, I would love to be able to know what the rules are that they're following. Why have they evolved, and how have they evolved to do this, so that, maybe we can leverage that in design. So, I'm interested in teams of robots that explore remote environments that we can't get to as people, like in the deep ocean or up in space or up in the sky.
And you've been studying this for a long time. And one thing I learned from looking into your work was the concept of exploring versus exploiting tension in nature and design. What does that mean?
This is a really fundamental notion. It's ubiquitous in nature. And it's this tension or trade-off between exploiting the information that you have, doing what you think at the moment is best given what you know, and exploring, which is a little bit riskier. It's saying, hey, I don't know what's going on. I'm going to try something a little bit new. I'm going to sort of divert my attention from what I'm focused on to see what else is out there. And so I have to balance as a bird in this flock, this explore, exploit tension. I always have to be kind of on the ready. I have to be exploring But how much I do that is really important, because it can be costly if I fail to stick with a group, or if I fail to spot the signal from the environment. So if we can uncover how animals have evolved, like birds have evolved to do this, and to do this again without a leader, it's a really rich advance. It helps us understand both how to design in this kind of resilience. It helps us to understand where ecosystems, where systems may be losing their resilience. So what are the limitations? What can we do to help or avoid creating more of a problem? Because a lot of those problems are maybe human-made.
One or two of them, yeah. Now, you've also found that starlings overall are aware of and react to about 7 of its neighbors. That this explore-exploit tension you mentioned is best balanced between those 7 flying friends. And you're using this knowledge as you develop these underwater robots. So tell me, what do starlings have to do with robots?
Yeah, they have everything to do with robots. I mean, they're really my inspiration. In our case, we are trying to develop robots to take measurements of a big area of the ocean. We're trying to understand the physics and the biology of the ocean and how that reflects big problems, like, can we use the data to help us predict when El Nino is going to come? There's currents, there's all kinds of turbulence in the ocean, and so much uncertainty. It really helps to have lots of sensors, and it really helps to have sensors that can move deliberately, to go expressly and to relate to one another. So think about them as like a sensor array. So they could spread out, or they could come close together. That changes the resolution.
And that in itself will give you more information relative to each other.
Exactly. For instance, if we want them to find where is the coldest patch of water, the highest concentration of spilled oil in the Gulf of Mexico, or if they're looking for, after a plane crash, if they're looking for the refuse, if they can start to see like a growing concentration of stuff. I mean, people have used this for tracking animals, for underwater archaeology, all kinds of fascinating things. And we basically tell them to move relative to what they're measuring in the environment, like temperature or currents or concentration of spilled oil, and relative to their neighbors. So if they sense, they measure that their neighboring robot has made a sharp right turn, even if the robot doesn't say, hey, follow me, if they just, they sense it through a camera or sonar, then they'll be programmed to say, hey, I'm going to follow this guy. And maybe I won't get too close because I don't want to crash into them, or I don't want to be redundant. I don't want to get too far, though, because we might miss something really important. So we want to space ourselves out, which is exactly what the birds do, right? Because if we all if we splinter as a group and we go in different directions, yeah. So the goal is to collect the richest in terms of information in the data that we collect.
Well, Naomi Leonard, professor of mechanical and aerospace engineering at Princeton University. Thanks for talking with me.
Oh, my pleasure. It's really fun to talk about. Thank you for thinking of me, inviting me.
Let's stay underwater, shall we? Our next audacious little thing is the Turritopsis dohrnii, aka the Immortal Jellyfish. Seriously. Dr. Maria Pia Mileta of the Department of Marine Biology at Texas A&M University at Galveston is the master of all things Medusa. She says that understanding the ways they stay alive may inspire some massive medical advances, so we can extend our impermanent Homo sapien existences for even just a little bit. So let's settle in, class, for a 101 on this audacious little hydrozoan.
Okay, so Turritopsis is a species of hydrozoan. And the jellyfish are tiny. They're 3 millimeters in length or so. And if you try to kill them, you starve them, you cut them, or you add some chemicals to the water, you injure them, they don't die. They form a ball on the container, a tiny, tiny ball that we call the cyst. And in 1 day to 2 days, they metamorphose back into the polyp. And the polyp is considered to a juvenile stage. because the jellyfish or medusa is the sexual stage of the cycle. And so it has gonads and is the one that reproduces sexually. And so the jellyfish response to damage is to transform back into the polyp. The polyp asexually will form a colony. So one polyp will divide in many polyps and form a big colony. And when the season is right, the colony then produces new jellyfish. The jellyfish come from the polyp, the bud of the polyp, and then they go into the plankton in the water column. And so for one jellyfish that doesn't die, there you have a new colony and hundreds of new jellyfish that can be injected in the environment.
You've referred to this as it's like a butterfly, but instead of dying, it turns back into a caterpillar.
Yes, it has been defined that way, but with the bonus that you get a colony of polyps that then eventually can release hundreds of new jellyfish in the environment.
So that's pretty cool. And as somebody who's had a relatively easy life so far, I am envious of this jellyfish. Of course, people who felt the cruel, raw metal blades of the meat grinder that is existence probably hope this jellyfish's secrets will stay with the jellyfish. But that being said, what are you personally hoping to do with what you know about the immortal jellyfish? Is there some ultimate hope to apply this immortality to human beings?
What I'm interested in is to understand how this animal is able, to escape death, and now it transforms from the jellyfish to the polyp, so the cellular mechanisms. We know that in this transition, there is a process that is called cellular transdifferentiation that happens, which is very important because it's part of the capability of cells to replace other cells that have been damaged. And so it's the capability of a cell that is adult to differentiate into something else that is needed at that very moment, right? And so we know that happened in the cyst, in this little ball where a dying jellyfish is transforming into the polyp. And where in the animals where it happens in a very long time. So transdifferentiation is diluted in 3 weeks. So that's a long time to understand the genetics of it, right? Which genes are turned on or off to allow a cell, an adult cell, to become another cell that is needed, another cell type that is needed at the moment. And so for me, I want to see if we can use Turritopsis as a system to understand cellular transdifferentiation at large. Because in Turritopsis, that metamorphosis from jellyfish to polyp occurs in a very short time, in 24 hours, up to 3 days. So it's a way shorter time than the regular process in other animals. And so here you have this system where you can induce this transdifferentiation in the lab in controlled conditions, and it happens in a very short time. And so it's a good system to understand the genetics of this cellular reprogramming. And so for me, Turritopsis may be a system that can help us answer questions about regeneration, cellular reprogramming, which are of general interest for us, as well as aging and senescent. How can this animal escape death? How does it repair its own DNA so that the animal can continue this cycle indefinitely? What happens to the telomeres, the tails of the chromosomes that usually get shortened up as we grow old and as we age? What happens in these animals? So I think the Turritopsis, apart from the fact that it's a very cool animal, can help us understand some general processes that we are interested in, right? The aging, the cellular reprogramming, the response to stress and wound. And so that's what I'm interested in.
How long have you been studying this thing?
I come from southern Italy, where this animal was described, the cycle was described. And so I was familiar with the animal since an undergraduate. During my graduate years, I wasn't studying Turritopsis per se. I was sampling other animals, and I collected Turritopsis in many regions of the world. And then I started as a pet project. I started working on the phylogeny and the evolution of this animal. And then it was so interesting, and nobody was working on the genetics of this animal, and I saw so much potential in it. And it was described, in the 90s. There was some work done in the 90s, and then nothing. And so I started asking questions: what's happening with this animal? Can we study? And there were, RNA sequencing was becoming prominent, new techniques, so we could ask new questions. And then I started studying it at the genetic level. Yeah.
So after all this time that you've been studying this thing, you have a really good idea for what may be possible, considering all the technology we have right now. And that's the thing about technology. You don't know 10 years from now. I have no idea.
We don't.
In your best estimation, what is the most likely use of all the information you've got on this thing so far in your lifetime?
In my lifetime, understanding which genes are involved in this cellular transdifferentiation, and if there are genes that are similar to what we use as humans, I use this system to model their behavior and possibly compare Turritopsis there is one species of Turritopsis that does this trick. Compare this species with another Turritopsis species that's very similar, but their jellyfish die. And so really uncovering what makes this possible by comparing the genome of one Turritopsis that is able to be immortal, if you wish, and another one that actually, if you try to kill the jellyfish, they will die. And so by looking at how they turn on and off the genes, and so the transcriptomes and the genomes of very similar species with very different capabilities, we may understand how Turritopsis adorni is able to achieve that specific life cycle trait.
And I imagine that a lot of people listening to this make the jump that, if we found this immortal jellyfish, then that means we'll figure out how to make ourselves immortal. And that's not necessarily the case.
Absolutely not. That is never the goal. We're really trying to understand the basic mechanisms of these jellyfish and try and see if there are genes in common with vertebrates, and this system may help us understand something about those genes and how they behave, and those processes, how they behave. I absolutely don't think that this will help us become immortal.
Although it is catchy, right? It's like this headline, this jellyfish being referred to as immortal, and the actual threat of immortality is one we like to ponder, even though it's totally impossible as far as we know. So that being said, what do you feel when you consider the possibility of a world with, let's say, a drastically extended life, thanks to whatever we learn from this jellyfish?
I'm all for extending the lifespan as much as we can. I don't think immortality in human would be good necessarily. And so, yeah, that's my position on that.
Fair.
No, it's a cool animal. It's also an introduced species. We find it everywhere, and it's spreading. It has a lot of potential. So we'll keep going on this species for a while.
Well, Dr. Maria Pia Mileta, Associate Professor in the Department of Marine Biology at Texas A&M University at Galveston, and the head of the Mileta Lab. Thanks for talking with me.
You're welcome.
After the break.
Something like the butterfly effect that I discovered reading a book on chaos theory, something small happening and affecting something far away and irrelevant to its existence, is a connection.
The poet Billy Collins on the butterfly effect. I'm Kyone Wolf. This is Audacious. Be right back.
Butterfly effect.
This is Audacious. I'm Kyone Wolf. It's funny when people say so-and-so needs no introduction and then they introduce him anyway, but I'll continue the tradition. Billy Collins needs no introduction. But he was the Poet Laureate of the United States from 2001 to 2003, and he was the New York State Poet from 2004 to 2006, and now he'll be known as the poet who talked about the butterfly effect on Audacious. I asked Billy to read that poem for me and Audacious producer Jessica, and then wax poetic about what it all means.
The butterfly effect. The one resting now on a plant stem somewhere deep in the vine-hung interior of South America, whose wings are about to flutter, thus causing it to rain heavily on your wedding day several years from now, and spinning you down a path to calamity and ruin, is, if it's any consolation, a gorgeous swallowtail, a brilliant mix of bright orange and vivid yellow, with a soft dusting of light brown along the edges. What's more, the two black dots on the wings are so prominent as to make one wonder if this is not an example of mimicry, an adaptation technique whereby one species takes on the appearance of another less edible one. First brought to light, it might interest you to know and possibly distract you from your vexatious dread with regards to the hopelessness of your future by two British naturalists, namely H.W. Bates in 1862 and A.R. Wallace in 1865.
Thank you, Billy Collins. One of the reasons why we wanted to talk to you about the butterfly effect is first, this show is called Audacious Little Things. It's a natural inclination to include the small butterfly. But that idea of one flapping of its wings to create this broader pattern that affects something so far away sort of takes your breath away. You know what I mean? It appeals to this strange human compulsion to wonder what happens next and what'll happen as a result of something. What is it about the butterfly effect that made you want to write it?
Well, first of all, thank you for having me on the program. And I love the name, the Audacious Little Thing. That's exactly what my mother called one of my high school girlfriends. She was short and she smoked a lot, but putting that aside, when I look back at a poem like this, I wonder, why would anyone possibly want to write a poem like that? I don't know. It's a very odd little thing. I'm not an autobiographical poet. Let's start with that. I don't write poems that really, I write them about my experiences, but most of them are mental or imaginative, or they could be a small experience, like looking at some water or something. So I try to write about things that are not me, so things larger than me often, and the butterfly effect is one of them. I've just always been fascinated by this theory that I think was concocted by Edward Lorenz, and he was he was a scientist, but he thought of himself mostly as a meteorologist. And I've read a book on chaos theory, and his chapter is devoted to him. And he used to get on airplanes and just fly around the country, not really wanting to go anywhere, but he just wanted to look at clouds from the top, just studying cloud designs, like clouds from both sides now kind of thing. And I've always just had this fascination with the possibility that some small event, like the butterfly flapping its wings, would have some effect on, for him, it was usually weather. He thought something might affect the path of a tornado or the occurrence of a thunderstorm. And I just kind of personalized that with this you, and no one in particular, but clearly the speaker is a sadist.
Clearly.
He's not a kind of a loving, huggy-duggy guy. He's someone who is impaired. This you is no one in particular in my life, but something's going to happen it's going to rain on your wedding day, and that's going to spin you into this path of calamity and ruin. So he's predicting all this horrible misfortune for this person. At the same time, he withdraws from her into a discussion of basically lepidoptery, right? The butterfly theories. He becomes this kind of cold-hearted scientist. And even at the end is giving the dates of the authors and the publication dates.
To distract you from your vexatious dread.
Right. Whereas this poor woman is still spinning down this horrible tornado of misfortune. So I guess it's the cold-heartedness of the speaker that once I discovered in the course of writing that I could have a cool-headed scientist predict this horrible future and yet point out to her, well, you might like to know that these two British naturalists, which would make you feel better at things. Anyway, it's sick. It's a sick poem.
Well, it's also not a long poem. It is a short poem. It's a little poem. And it reminds me of the Mark Twain quote, "I didn't have time to write a short letter, so I wrote a long one instead."
Well, as a poet, if you look at this as a formalist, and these are the things I do when I construct a poem, it has 2 stanzas of equal length. I mean, most people don't count lines, but it's 14 lines and 14 lines. And that's called a hinge poem. So the 2 equal stanzas kind of invite comparison. And a change does take place between the first and the second. The other thing to notice is that each of them is one long sentence. And see, you didn't notice this. This is why I'm here.
You saw my head just perk right up.
Well, you just kind of woke up there. But these are the things I'm thinking about. And that's why it's a little, I think I read it okay, but it's a little hard to read because the sentences are very long and complicated because this speaker, this sick disaster predicting is a complicated person.
Beautiful. Jessica, you had some thoughts.
Your poems and poetry in general often zooms in on little things. And there comes our Audacious Little Things theme again, to convey a much bigger idea. So, for example, in your poem, Aimless Love, you fall for a bowl of broth, steam rising like smoke from a naval battle. And I'm wondering how this focus on detail affects the way that you see the world. Do you go through the world always paying attention, looking for these concrete observations that could eventually lead to a poem?
Well, not all the time. I mean, Seamus Heaney said he's only a poet when he's writing poetry or reading poetry. We're basically wandering around, but I do have, I mean, like the butterfly effect. As a poet, I see experience. I walk through the day, maybe looking for metaphors, or not looking so much as being receptive to them, being open to them, and also to being open to just possibilities. The thing is, there's only 4 or 5 subjects or maybe 7 in poetry. I mean, it's like love and separation and mortality and spiritual aspirations. This is a handful of them. And someone said there's only 2 stories in science fiction. Either we go there or they come here. But there are a plethora of metaphors and a plethora of things in the world. The Chinese used to say the 10,000 things. Well, there are lots more than that, but it was meant in those times that would be like millions, I suppose. It would be a lot. So something like the butterfly effect that I discovered reading a book on chaos theory some years ago, I would certainly make a kind of mental, maybe a real note about that and about how something small happening and affecting something far away and irrelevant to its existence is a connection. Metaphors are basically connecting 2 different things and 2 very different things, usually if they're good metaphors. And that's one thing that's impossible to teach in workshops is an appetite to connect things. You really have to enjoy bringing 2 things together that maybe nobody else has. And that is a kind of original connection in verbal terms, but also in synaptic terms. Often something in one part of your head and another part gets connected by a metaphor. And there's often kind of a new synaptic path burned open there. I mean, who knows about the neurology of poetry, but that's a guess. Anyway.
It's another audacious show.
Yeah, and I've done that without, opening your head up and looking inside, so painless.
Well, Billy Collins, thank you so much for reading that poem, and thank you so much for talking with us.
You're very welcome. It's been a pleasure.
Audacious is produced by me, Jessica Severin DeMartinez, and Katie Tolarski at Connecticut Public Radio in Hartford. To subscribe and listen back to shows about things like the antinatalist philosophy that it's immoral to have children and we should collectively self-extinct, what it's like having your arm ripped off by a tiger, and then having it be featured as part of a Netflix series, profiles of people who have an ultra-rare condition where they're able to remember almost every day of their lives as if it were yesterday, why news anchors talk like that and what happened when one brought her anchor voice home, or how a woman communicated her way out of locked-in syndrome using blinking, visit ctpublic.org/audacious. Send me your reactions and show ideas on Facebook, Instagram, and Twitter at Kyone Wolf, and my email is cwolf@ctpublic.org, and online use the hashtag AudaciousPublic. Thanks for listening.